So welcome you all. The topic of the lecture is Baeyer-Billiger reactions, Chichibabin reactions, and here these reactions are further as is being having a great importance in organic synthesis. So here if we see in each of the reaction, we will see the example of the reactions as well as their mechanism. And in case of another reaction like Chichibabin reaction, here also we will discuss the reaction as well as their mechanism. How does these reactions are being uh, proceeded further, and what kind of products they are being make at the end of the reaction. So here starting with the Baeyer-Williger reactions. So this reaction is an organic reaction in which ketone is oxidized to an ester by treatment with peroxy acid or hydrogen peroxide. So the key feature if we see in case of Baeyer-Williger reaction, oxidation reaction, are its stereospecificity and predictable regiochemistry. So it is named after the German chemist John uh, Friedrich Wilhelm Adolf von Baeyer in 1835 to 1970, and the Swiss chemist Victor Villiger in 1868 and 1934. So they had worked great in these kind of the synthesis, and they are succeeded to synthesize these oxidative compound, which is you can see by the application of peroxy acids like acetic acid and hydrogen peroxides, and also aromatic acetic acid or peroxyacetic acid peroxides. So here if you see in this case, this is a ketone has been taken up in the starting, and here this per acid has been taken up during the course of reaction. So this is reaction is further oxidized. One more oxygen atom is being attached in the reaction. So this reaction we can see how does this is being accompanied. So here if you see the reagents typically used to carry out this rearrangement are metachloro per oxybenzoic acid. We can take peroxyacetic acid, peroxytrifluoroacetic acids, and reactive or strained ketones like cyclobutanones, norborenone, and react with hydrogen peroxides or hydro peroxides to form lactones. So here the lactone formation, it means there is the insertion of the one more oxygen atom in the, like in case of ketone, as you seen in the previous slide. So the original reagent in 1899 he has published is carrot acid, discovered just a year earlier, and this carriage acid can be also being discovered at the same time when this reaction is came into existence. So if you see the mechanism, so the mechanism of reaction, as I said, it is an oxidative reaction, and oxidation is being taking place. So the oxidative cleavage involves first addition of the peroxy acid to the carbonyl, forming a tetrahedral intermediate. So the here we can see the how does this reaction is going through. So the transition state for this step is in as a hydrogen relay involving three peroxy acid molecule with linear OHO interactions. Here we can see OHO interactions. So in the next is a concentrate migration of one of the adjacent carbon to oxygen with loss of a carboxylic acid. If the migrating carbon is chiral, the stereochemistry is retained. So if this carbon is a chiral carbon, so their stereochemistry will be retained and in the product. So here you can see how does this is being interacting with this HOO, OHO, you can say. can be interacting with here. So this is getting to be attached, this oxygen. You can see here this R1 R2 is alkyl groups ketone, and this oxygen you can see here is going to be this parasitic acid is attached over this oxygen with this carbon by the sigma bond, and after the protonation, after in acidic condition, so this inserted in this substrate, one more oxygen is being inserted from here, and the rest of the acetic acid being formed during the reactions. So here the this oxygen is being inserted, and this is, you know, the oxygenated product has been formed with this reactions. So if we see here, so the migratory aptitude is like proton will be higher than tertiary alkyl cyclo hexyl, secondary alkyl aryl, and is greater than primary alkyl and methyl. So in the transition state for this migration step, the RCO dihedral angle should be around 180 degree in order to maximize the interaction between the field RC sigma bond and the anti-bonding oxygen sigma bond. So this step is also assisted by 2 or 3 peroxy acids unit, enabling the hydroxyl proton to shuttle to its new position. So these are certain conditions in which this reaction is more favorable as far as their dihedral angle of the RCOO of in these different atoms. So in between their dihedral angle, so that will maximize the interaction between the filled RC sigma bond and the anti-bonding oxygen sigma bond. So these are all conditions asked for the feasibility of the reaction, whether the reaction will go in a proper way or the reaction will be feasible or not. So these are the conditions you can say. For unsymmetrical ketones, the migration group is usually the one that can be best stabilize positive charge. Thus, the cyclic ketone produce lactones, and aldehyde usually produce carboxylic acid, although formates can also be formed if the migrating group is tertiary or an electron-rich vinyl group or aromatic ring. Sometimes the alcohol is formed when the formate is hydrolytically unstable. So here, if you see now the another reaction, which is Chichibabin reaction, is a method for producing two amino pyridines derivative by the reaction of pyridine with sodium amide. So this is the conditions. It was also, you know, it is reported by the uh, Alekesi Chichibabin in 1914. So as per his name, this was he has reported this reactions. So the name of the reaction is being put forward in his name, Chichibabin reaction. So the following here you can see the overall mechanism of the reaction. So here the important thing is amino, you know, compound to amino pyridine derivative is formed by the pyridines, substituted pyridine. If you see here, the alkyl substituted pyridine has been taken up, and sodium amide is being, and also the ammonia gas can be passed during the course of reaction. Here it is thermally this reaction is being exceeded in presence of water. So here if you see by taking this substrate initially like pyridine, so this is forming in presence of sodium amide, a substituted, or you can say with respect to this nitrogen, two amino group is here amino pyridine, a derivative which is being formed at the end of the reaction. So, however, the direct amination of pyridine with sodium amide takes place in liquid ammonia. So here we have to take the ammonia in a liquid form. So the following the addition elimination mechanism: first a nucleophile. Here in among this will dissociate like Na positive and NH2 negative. So this NH2 group will act as a nucleophile, is added in this react here, and while NH2, while a hydrogen is leaving H negative in a form of H negative, it is being leaving from that particular position, and then this amino group is going to be attached with the second position with respect to this nitrogen in 2-amino pyridine. So here the 2-amino pyridine substituted derivative has been formed. So here the Chichibabin reactions, the mechanism is an addition elimination reaction that proceeds through an alpha adduct intermediate. So first sigma adduct intermediate. So first the nucleophile, which is here is amino group, adds to the delta ring carbon, pushing electrons onto the ring nitrogen and forming the anionic sigma adduct, which is stabilized by the sodium. So because since NaNH2 you are taking, so that will be stabilized by the sodium, which is being dissociated during the course of the reaction. So the electron from the nitrogen are the pushed towards the ring, forming a carbon double bond nitrogen bond, and ejecting a hydride ion. The hydride ion abstract a hydrogen from the positively charged nitrogen, forming hydrogen gas. So in here, the ring nitrogen then push the electrons back into the ring, regarding regaining aromaticity. So the new negatively charged NH groups abstract a proton from the water, giving the product at the end of the reactions. So here if you see the reaction mechanism, so here the NH2, as I said, it will work, the NH2 will attack at this carbon. So here this is the double bond is being shifted in the high electronegative atom. This is nitrogen here. So here the high electron density will be in on nitrogen. So here the sodium ion is also in the solution. So this will attack over here. This will be here in this case. So NH2 will be attached over this carbon, and hydrogen is being replaced like here by taking their as in a their electrons here. So now this NH2 is being can also, there is some rearrangement can be possible, rearrangement can be there. So this can be, you can show like here directly in this, but here if you see this with the water molecule, this NH is now abstracting the proton from this water molecule which you are taking in a aqueous medium. So this is also, there is a this kind of rearrangement can be also possible. So these are the possible rearrangement has been shown over here. And after, since the hydrogen gas is being passed over here, so this hydrogen is getting to be attached in a form of this, so NH2 group is being formed out. So finally your amino groups, amino substituted or 2-amino pyridine is being formed during the course of the reaction. So this overall possibility has been shown over this reaction. So you can easily identify there are number of possibilities as far as the reaction intermediate is here. So these can be formed. So after all overall discussion, we discuss about the Baeyer-Billiger reactions and their mechanism, and Chichibabin reactions and their mechanism. So after the overall discussion, there is the questions which can be practiced, which can be important to understand it in a better way. So the question or problem which can be framed out from the overall discussion is like how you will explain the Baeyer-Welliger reactions and its mechanism with suitable example. And another question which can be in a broad question here with I am just putting like how you will show a reaction mechanism for the Chichibabin reaction. So you all need to practice these questions, which is important as far as the to understand their mechanism and their importance in a better way. So here you can see the materials presented here in this lecture has been taken from various books and internet websites. So this material is only instruction material and is being used for only instruction purpose only and having no commercial use or no commercial application or commercial use of this lecture. So online content also has been taken up here from different sites and sources, and some of the books which you can study further for in going for in more detail of such examples for better understanding. So thank you again and thank you so much for your patience.